Hello, everybody. It's great to be talking at the API Days conference and the APSEC University track. My name is Malcolm Sparks. At the APSEC University, we were talking about the security problems with building APIs, and I wanted to present a data-driven approach, which I call building a secure API platform. This is something that I've been doing for a number of years. I started out in the 80s learning how to program, and in those days there were really only two choices. You had super easy, which was the basic path, and super complex, which is machine code. But then things got a bit easier, and over the period of my career, I discovered the Java language, and I got very excited about the potential of writing, software in Java. And then in the last 15 years or so, I've been working as a Clojure developer. So I've really come to this topic from an engineering background, and this is a presentation for people who are developing APIs internally or externally for businesses and are concerned about how hard it is to build secure APIs. So I've been working on trying to make it easy to build APIs for a long time. I started out with much more primitive technologies in Java, server-side Java. And in those days, we were building interface definitions in Corba and RMI and servlets. And I was very early in working in a technology called Enterprise Java Beans. So these were much more kind of object-oriented technologies. And today we have the web and HTTP, and most APIs today are something that are built in JSON. And we sometimes call it a REST API, in that it's an API that uses the HTTP verbs of get, put, post, delete, and tends to be about sending representations in JSON to and forth and communicating in that way. Since about 2010, I've been involved in trying to create much easier approaches for APIs to make it more automatic rather than having to code APIs almost from scratch. And in the last 3 years, I've been building a technology based on a database, and I call that technology Site. I'm a founder of a technology consultancy called Juxt, and we were founded in 2013. Really, we're all about simplicity. Most of the problems that we discover in IT are all down to the same monster, and that monster is complexity. Complexity gets everywhere, and it actually makes some things much, much harder, particularly security. So this is really the theme here, is about trying to make life simpler and to try and work out how we can bring simplicity back to our complex landscapes. So what is Site? Well, really, it's just a web server backed by a database. That in the way that we normally write APIs, we use web frameworks. And in a web framework, we might have something like a router. And what a router will do is take the URI that every URI will have some kind of resource behind it, and there'll be some code in your program that will take that URI and figure out which function or handler or procedure to route it to route the request to. And that procedure will have to be written almost from scratch. And the site works quite differently in that the web resources are still keyed by URI, but those are living as documents in a database. Now, why in a database? Well, if every document is in a database, you can see it, you can query it, you can find it, you can pair it with other documents, you can run algorithms on them. So data, we believe, is kind of one of the tenets of Juxt, is that data is better than code. Code is opaque, code is dark, you can't see it or inspect it or query it. So each document in Site represents a resource at a current, or a representation of a resource at the current time, and that data document has all of the hints, the resource metadata, by which a web server can handle a request more automatically than the programmer having to do that manually. So for example, features like content negotiation, where there is some between the client and server, some agreement as to what type of what format or what media type of representation the client would like, or conditional requests. And this is where a client says, I already have a copy of a representation, I just want to get a new one if it's out of date. And things like caching and lots of other facilities in HTTP that really most programmers don't get around to doing. And this isn't too much of a problem when it's just things like HTTP semantics, we can get by. But when it's things like API security, it's much more important that it's built in to a platform like Site. Site has this concept called operations. Operations are triggered by you doing a request with a particular method on a URI, just a typical web request, but it maps to an operation. And that operation itself is defined in some code. Those code operations we won't delve into too much today, but those are themselves resources. They can be queried, they can be accessed and introspected. Also in Site, web resources can be bundled into reusable bundles. So we have bundles that enable us to just plug in, snap in OpenAPI or OAuth 2 support, or just really allow you to upload your own API. So we have APIs for session management, for the creation of access tokens. It's all very plug and play. In particular, though, being able to just plug in OAuth 2 and make that automatic is something that is much needed today. Too often we're creating APIs where we have to do the plumbing ourselves as developers, and we have to there isn't much support for the creation of access tokens that can control our access to our API. Also, another big problem that we have in API security, in fact, the number one in OWASP top 10, is this problem of broken object level authorization. In fact, that is number one. Broken object level authorization is really about missing access control or badly configured access control. Access control is really saying, does the person calling this API have the authorization to do this action on this resource? And those determinations are very domain specific. They could depend on what you're trying to do, and it depends on what domain you're in. For example, a patient in a hospital might have to consent to have their medical records being accessed by the radiographer. That is a consent-based access control, and all of those terms and nouns I've used are very domain specific, and that is why it's very hard to create permissioning systems in a black box far away from the API itself. In a way, access control is all about the metadata of the data that you're serving, and therefore for me, access control has to live right next to the data that it is authorizing access to. Site is 100% open source, and it's written in the Clojure programming language. So we've talked about broken object level authorization being the number one issue in the OWASP top 10. And here I'm just going to show in the demo that I'm going to give, I'm going to show how we bake in support for access control, just so that you don't have to worry about it. And now I think that this is one area where the industry has really run out of ideas. We don't know how to fix access control properly because we're always trying to build things as separate services that are apart from each other. And we're not very good at solving problems where we need true data integration really close. And a lot of microservices architectures suffer from this problem. And the very fact that broken object level authorization is at the top of a top 10, number one placement in the top 10, really goes to show that we need to radically rethink our approach to access control. And there are some ideas within Site which may point the way forward. So Site is not an API gateway. Site lives right next or wraps an existing database. In my demo, I'm going to show the site wrapping a database called XDDB, which is a bitemporal store that has been a database product that Juxt has been working on for 5 or 6 years. But the principles here that I'm going to demonstrate are the same. I wrote this diagram some months ago to sort of describe that site can act as a kind of data mesh product. It is really there for a department to serve its data as a data product, but not just data product of the past, of the analytical data, but also to provide a data service for transactional and operational data coming in. And I call that data in the present versus data in the past. Okay, well, we've talked about broken object access control. ABAC is attribute-based access control, and this is access control which depends on the attributes of the resource that we're trying to access. It could be that we allow only the owner of a document to update the document. And therefore, we have to figure out, well, who is the owner? It's not enough, for example, to give a bank manager or account holder access to all accounts. Of course, it's important in a bank for an account holder to only have access to his or her account and nobody else's account. So that's why it's hard. Other things like authentication and rate limiting can be done outside of the domain. Authentication is a well understood problem. We have users, sometimes we have roles, but essentially that is common to every domain. Likewise, rate limiting is something that can be done in a network, in a firewall, in a reverse, in a product like Apache or Nginx. It isn't by itself domain specific, unless you want to use some attributes of the resource to influence the rate limiting, but that's uncommon. My belief is that in creating this site product is that making it open source and allowing it to run on your machine rather than just something in the cloud means that you build and test your application API, but together with its security rules. And so you get to build security from the get-go. Security shouldn't be something that we forget about as developers and we wait until make that an exercise for the DevOps team or the security team, because in truth, they may well not get around to it. And many of the vulnerabilities today are caused because we haven't developed as developers, we haven't considered access control and all the other security aspects in our coding and testing locally. We have too often just assumed that somebody else is going to pick up that task. And I think this is really at the root of the problem of access control, that we don't have the tools in order to build secure apps from the get-go. Site has a permissioning model. There are many ways of doing permissions. I just want to explain some of the technical aspects of this. So I mentioned before that every request maps onto an operation. In fact, if you think of an open API document, every combination of path and operation maps on, a get to customers maps onto something called an operation ID. These are optional attributes you can add to OpenAPI. So if you think of operations, these are business-like domain operations, like create customer, refund account, extract medical details for insurer. These are very specific tasks we want to expose, but at the point of defining each operation, we're defining what we want the operation to do from a database point of view. What actual changes do we want to happen? For example, transfer funds would decrement an amount of money from one person's account and credit to another account. So there is the what should the operation do. But the nice thing about making these documents is that we can also define who is allowed to do that operation at that same design time. Many of these operations really are dependent on the person who is doing the operation. So we have this idea of an operation, and each of these questions of should I allow the user to do the operation look for other objects in the database called permissions. These are like little switches. You can put permissions in, you can revoke permissions by just deleting them. And because I'm using a database that is a bitemporal database, get to track those permissions over time. So I can rewind the clock and ask the question, why did this user have access to this operation at a particular time? But really, these permissions are something that just live as records in your database. Again, there are different ways of doing permissioning schemes. This was really the simplest. I took many different authorization schemes, went through before I found this particular simplified model. Operations define the query and matching logic for the permission. So they always say things like, well, find me a permission for that allows a particular user at this time to access documents that they own, which are related to this resource. These access control rules are often written as a set of equations or a set of constraints that have to be matched. And typically we use these kind of triples or data log-like languages, like Open Policy Agent has a language called Rego, and there are other similar types where we tend to use data log rather than SQL, but you just as easily use SQL for this. Okay, if you wanted to install Site, you could run it today in Docker. This is how you would do it. And when you start up Site, as I'm going to show, we need to sort of initialize it with a few basic resources. When you start it up, the database is empty. And I'm going to show that now in a quick demo. So here we are. I've started Site and I've got a terminal up, and I'll show you. I have a few resources. These are all documents. I can show a particular document with. Let me find a piece of data called Saffron. This represents a pet in this fictional pet store, and there's some data. This is just a JSON document, but there are also some extra properties in this document that indicate that this pet has a number of allowed methods. In this case, get, delete, and post. And you can see that when I call one of these operations, I'm going to be hitting another resource. This is an operation, and this is also defined in the database. But I'm going to reset the database so it's empty because I want to build from scratch. So I'm doing a quick reset, and now we have nothing in the database. Now, the first thing that I want to do is initialize the database with init. This installs just the minimal set of information in the database for us to remotely access the database to do things remotely. So this is the only thing that has to happen on the command line. From now on, we have just enough resources for me to connect to this database via a UI. And we have a UI called Insight, which I could click on this link and it would then talk to my own database. Or I can go and carry on using the command line. There is a little, there is a OAuth 2 registration of an application here. This is quite technical, but the point of this is to a database to allow registered clients to access an owner's data, user's data via the web using OAuth 2. So we have to have some way of registering applications here. And in here we've got a simple application called Site CLI. Now this won't allow me to, I can't use this application, use this yet. I can see that doesn't allow me to. So I need to go and request a token. And that has been saved here. So now I can type something like users, and I see no users. Okay, now I'm going to install a little bit of Open API support just so that I can show you the system API. So I've installed that now. Now we've built up just enough into Site so that it can serve up a system API. And we can do things like ask, well, who am I? And here we see unauthorized. That's a 401 because I haven't authorized the Swagger app that I'm using to contact my database. So let me do that now. So we click on here. We do actually have some applications registered. One is the Swagger UI. So I'm going to type in the client ID Swagger UI, select these and hit authorize. And now I'm faced with a login form. Of course, I can configure site to point out to another identity provider, but there is one built in which requires you to authenticate through a form. And yet here I have not at the moment. I don't have any users, so I need to register one. So I'll do that now. That's good. Okay, so now I'm going to type mail API days password. And we've authenticated ourselves to this authorization server that is built in to site. You could use another authorization server like Curity.io or anything that implements the OAuth2 specification. Now, when we're building an API here and a secure API, there is this concept of a resource server, which is the API that I'm delivering, that I'm building, and then there's this side API called the authorization server, and that is a third party that's going to be the issuer of the tokens that I'm going to use to authorize the applications connecting to the data. So here I've got a number of scopes. I'm going to select them all there. We'll go quite quickly. And now we're logged in. We can do our who am I call again. You can see here that it's 200. I can see I can see my user now, which is Mal. Okay, well, let's see if I can do something like get users from, again, the console. And here, I don't get a 401 because I have authorized, but I'm forbidden because Mal is not yet allowed to call this users. Now, this is behind a sort of role-based access control, and I can actually, on the command line, because I'm logged in as an authorized user who can make these grants, I'm going to assign the Mal user a role of site admin. That's a built-in role. That means I can now execute this, and I can see, of course, one user. This is a concept of security being built into the platform from the get-go. I haven't had to code anything yet. This is all really part of a building up exercise for us to get to the main deal. Really is being able to define APIs yourself in OpenAPI and just upload them again to the platform, implement those operations, and really have think of it as a mock API server, but with much more. A mock API server that's connected to a database, which is actually a real API and can be the heart of your data product in a department or organization. So let me show that. So this is where I already have an API kind of in my demo. I'm going to install that, install OpenAPI, and that's all that I have to do. It's that quick to install an API and update it. So let's go to that API. Here we are. If I wanted to make a quick change to that, let's change the title. API days, install it, and refresh. So this very, very fast iterative cycle means that I can design the API quickly with its operations, and I can have a very fast turnaround work process. This could even be a production server, but what we're doing here is just declaratively and remotely configuring functionality very quickly. So that's all I have to show. I'm going to show this get pets, we're just going to implement this API. This 500 is because I need to install some operations, so I'm going to do that now. Just install. I can look at a number of bundles, and there are some to do with the pet store. There's operations, so I can install that pet store operations. And I have a look. Yeah, okay. I've got 401 now, so that's progress, but I need to authorize. So we'll authorize as we did before. I'm going to install the application, the pet store app. And that means that I can now log in with pet store, or rather, I can authorize the application as pet store. Again, we then have to authorize pet store. We know that I'm logged in as Mal, so I can do that. I'll select that. And now I can try pets again. I get a 403 because I'm not actually, Mal is not a pet store owner. So I'm going to assign that role. At work, but I've got an empty list of pets. So I'm just going to put the pets in. So I'm going to assign CLI to be pet store owner. And I'm going to install, I'm going to seed the system with some pets. A 403 there, but that's because I've got to give myself a, I'll log in as Mal to do that, because Mal is already a pet store owner. I'm going to give Mal the role site admin, request a token as Mal. So here I am logging in as an actual person rather than an application. I have an access control. I can do things like who am I, and now I can install the pets, and I can execute here, and I can see a whole bunch of pets here. So this is the end of the demo. It really shows, should show how quick it's meant to be to use Site, and you can kind of get a sense of what the developer would be going through building a secure application with security built in. We haven't really done any coding yet. There is some coding to do behind the operations, but essentially every aspect of API security and HTTP and method semantics and all those conditional requests and everything is all built in to Site. So the only thing that we have to focus on is the business functionality itself. So that's the end. Thank you very much for listening. If you want to contact me, I'm very, very pleased to get any emails around this topic or anything else I've been speaking on. Do just feel free to email me at mal@juxt.pro, or on X, I'm Malcolm Sparks, and at GitHub. So yes, be very nice to hear from you if you've got any related ideas, if you found this useful or you have any questions. Thank you very much for watching, and hope to hear from you soon.